Buenos días. Buenos días. I get to hear my voice. Nobody's here. Let's see what's happening. Okay, people are coming. Hello. Good morning. All right. If the screen is blurry, refresh in the live stream. So, last class I left you with all the documents for the second module, and I asked you to review them on your own, and I did say I was going to solve the test. Oh my gosh, I didn't give you the test grades yet. I have to put that on my list. I apologize. I just remembered. So I will give you those. They were pretty well done from what I saw. But I'll give you the details today. Okay, later today. I'm putting this on my list. All right, so you have all the documents for module, what I call module 2 or unit 2. And how's it going with your review? My idea is to work on finishing the one that we started, 2.4, and then picking maybe one question from each document, problems that you would like me to do, and then I can give you more problems if we still have time. Then I want to get into module 3 or unit 3. I'm just going to check if I sent you every document. What's the last document? What's the number on the last document I sent you? Oh, I think I gave you them all. And I even gave you the prep questions. All right, so we have lots to do. I did already give you the prep. That was on the 10th, so 2 weeks ago. So you have all the documents. So I will do one problem from each document and encourage you to complete the documents, and then I can answer any questions you have about the documents in Unit 2 by office hours. We can meet and record and mount on YouTube our review, okay? All right, so you have everything in your power. So let's see. Is that okay with everyone? Is there anyone here who already reviewed everything and would like me to start Unit 3? I'll need to take a moment to send you the documents for Unit 3. Okay, let me try and make this a little bigger. All right, so we left off here. How much of the first 3 mortgage payments goes towards principal and interest? That's from this question, okay. So you have negotiated 25-year, $100,000 mortgage at this rate. And I guess we should do question 1. I don't think we did that. Let me do this. All right, let me clean this up a bit. Let me just take the question and my goodness, that's not what I wanted. So that's the problem. The first question is, what's the monthly payment? So, did we do this already? You can tell me. So I thought we just finished with the bond problems. All right, so it's, yeah, I do think we finished this one. And what we found was the payment, right? We solved for the payment on our calculator and we got $732.50. And I told you, you have to round it and that number needs to be used. You also have in storage, well, I guess we'll have to put the number back. For the interest rate, we'll need that. So we were told that this is our interest rate per year compounded monthly. So that's an R112 from my notation. If you don't want to write that, it's fine. Just remember that what you do about it is turn it into a monthly rate because payments are monthly. And when you do that, you get the decimal. Well, I've put it so that I get the percentage value. That's how it should look on your calculator. But anyway, store it. Now remember, this is the decimal version. So as a decimal, you don't have to multiply by 100 to use it. Okay, just be clear what you stored. So now, using this information, so set that up for yourself. That I'm just checking my clave. So if you did this as decimals, there'll be 2 zeros in front. All right, so in the next part, next question. I have to just prepare my screen to see your comments. Okay, so the next part is to create the amortization table. This is the tabular way. You can do this in Excel. You have to set it up properly. To do it, you can solve problems like this, or you can solve problems using your annuity function on the third row, the time value of money row of your calculator. But I just wanted to point this out so we have an idea of what's happening. So let's fill in this table to answer the question, how much of the first 3 payments goes towards principal and interest? So in the first month, this is a $100,000 loan. Payments are monthly, and we have the monthly rate stored in a calculator, right? So the outstanding balance at the beginning is what? Now you guys do have the clave, but try not to look right now because we're doing this together. It's the $100,000. So interest charged in the first month is determined on the balance. You need to take your interest rate that you have stored, multiply by column A, or 100,000, and you get so this is the interest charge, which seems like a lot of money. Okay, that's just the interest charged. So the payment at this rate, we figured out that the payment would be $732.50. I want that blue. $732.50, and that's going to be $732.50 every month for the next 30 years. Is it 30 years? 25 years. And now you want to figure out how successful are you at reducing the balance. Well, 732 minus this is not a lot, but it is something. So for the first several years, your payment will mostly just be on a matter of paying off the interest, and it changes. Jose, I'm reading your comment. I'm not sure what you mean that Laura in YouTube. You're talking about, Jose, are you in my other section? My other section is a distance class, and I invited the students in the other section to join. But this class is scheduled Friday mornings. The other class is a distance class, so everything's online. So Jose, you'll have to tell me because I guess I could look at my class list to see which section you're in. If you have questions about the class, you guys can email or text me, and I can discuss it because I need to get through the material right now. I prefer to stay distance because that's how we started, and I think people made plans to work by distance. If we go in class and some people can't make it, that's that's not going to work out. And this section is a Friday class. This is a Friday morning section. Anyway, we can talk about it later. But I think it's too, it creates too much uncertainty, I think, unless I give a schedule. Okay, so the principal outstanding at the end of the month you need to take your principal amount and subtract the amount you paid down and put it here. It doesn't fit. Then we move that here. And repeat the process. Multiply the balance outstanding by the rate on your calculator. And you get this amount. And then the reduction, how much did we reduce the principal? We're going to, again, take our monthly payment, minus off the interest, and you'll see that each month we pay more and more towards the principal because the balance has gone down. So the balance is going down. And the reduction is going up. And that's because the balance is going down. Questions? This is an amortization table, that's right. Diego, what is nope supposed to mean? Did I ask a question and you said nope? Okay. I guess I said no, any questions, and you said nope. All right. Let's see the balance. Okay, thanks. All right. So that is the amortization table. And now let's answer the question, how much of the first 3 mortgage payment goes towards principal and interest? So these are the answers, these 2 columns. And the interest payment decreases as the principal reduction increases. So in a mortgage in Puerto Rico or the United States, these payments are tax deductible. So you reduce your taxable income by these amounts, which is quite good in the, for the, as far as, claiming or reducing your payable taxes. But it does go down. So in the first years, it's going to be a nice reduction in your tax bill. So there are incentives to purchase property that other countries don't have. Canada doesn't do that. So it's a nice way. Well, there's an incentive to buy rather than rent. If you're going to not only have an asset, you're building value in an asset, but you're also reducing your taxes paid. Questions about what I just said? So interest is a lot. It's a lot. And it's monthly, so you can see it's compounded. It's a lot of money. So the next question is, what is the total amount of interest paid over the 25-year period? So it's really good to go through these exercises to practice answering these types of questions. So then when the test comes, you know where to find everything, okay? I recommend you print all these documents. Some students are comfortable with the items on their computer or their tablet, but there might be some key documents that you would need to print. I leave that to you, but I highly recommend it. Maybe next semester I'll make a book of notes students can purchase. But I don't have that right now, so I leave you to print it. Okay, so how do we solve this? Well, there's going to be 300 payments. And there are 300 payments. And so 300 times 732.50 is equal to, well, let me say the answer. So that's going to be the total amount of payments you make and then we subtract. What we're actually paying down, right? We're trying to pay down the principal amount. So the answer is the difference. What does it give you? This portion is 219, so it's in terms of interest, alone, the payments that include interest in the payment, right? Less and less every period, but it includes the interest. The payments are double the principal amount, and that is usually the case. So interest alone is more than the value of the property. So what do you think about that? Comments? Any comments? Job? So why would people do this? Why would people set themselves up to buy a property that looks like it's worth this amount, but they end up paying double? Well, they have every year they're increasing their equity or their shareholding or their ownership of the property, because really the property belongs to the bank, or if the investor sold the loan to the if the bank sold the loan, which they can do, it belongs to the investors in the bank. So even though you have the title, as long as you are paying the mortgage payments, it's your property. But if you stop paying, there'll be a problem, and it will be lost to or it'll be foreclosed, and the bank will take it, or the investors will have it. So why do people do this? They do this because, I think they anticipate that maybe by the time they've paid it off, they've stored the value in the real estate market, because over time prices in the real estate market go up. So this actually is a way to retain your purchasing power of buying a home when you're ready to buy one, because you can then sell it for a higher price and then have the equivalent to move into another home. If you're just renting, you don't get to do that unless you use your money in savings and you save it or invest it, and the money increases in value and makes it possible at some point you can buy real estate. But so that's one reason, to maintain the purchasing power of a home by owning a home. Another reason is, in the United States, as I explained, you get to reduce your taxable income, which is awesome. And you'll see when we get to it, unless you already know, this is quite a lot of money saving. So I can get like $5,000 a year as a result of just deducting my interest payments on my home. That's quite a bit. So you could reinvest that, or you can use it for future payments of your mortgage. Okay, so there's some considerations. Now you can look at the bad side of that. What if house price values do not go up? That could be a downside to this strategy. And so you have to consider all these factors, the tax, anticipated taxation over the coming 25 years, which is hard, right? You have to think about the future. But history has shown us, although markets go up and down, they net out over such a period, they net out positive. So, meaning housing market does go up. And as far as taxes and tax deductions, you can pretty much guarantee there's going to be taxes. Okay. So anyway, so you would be able to look at these different factors and determine if it's worth to buy or to rent given your disposable income. If you don't have the money to get a mortgage, well, that's a whole nother thing. Okay, so think about that. And let's answer the last question. Again, try not to look at the answers, just think of this through together. Let's see how many people are here. See what I mean? Like half the class is here. Half the class is attending because they've made plans to do other things because they'll watch this video later, is what I hope. If I start saying we have to be in the classroom, I'm concerned we're going to lose people. All right. And it's going to be really hard for me. Well, I'll say really hard. I have to think about if I could broadcast at the same time I'm teaching. It's just a lot more technical issues, a lot of technical problems that I could have. So my idea of making this hybrid was just to do the tests in the classroom. But students seem to want more time to complete the tests anyways, and it looks like it's better to do that by distance anyway. What we could do is I could have review sessions in the classroom, or you guys can come and do problems and we can sit together. I would favor that, and that would have to be probably after the class, Friday afternoon, something like that. So it would be like office hours. Okay. All right, so assuming the mortgage rate remains 7.4 for the remaining time of the mortgage, after you have paid 2/3 of your monthly payments, what is the amount still remaining to be paid? So 2/3 would be so you would have paid off 200, and so the next one would be at the 201st month. So what we're talking about is, like, think about this table, and what we're asking is what is the principal at 201? 200, sorry. At the 200 month, actually it is 201. So 201st payment will be also $732.50, and that makes a that makes my timeline look like this. Okay, so remember, if the payment is here 201, then the next one is 202. Etc. This is just an annuity. This is just an annuity. This is annuity with the principal amount at the 200th year. th period, 200th month. We put the rate here. And the number of payments. How many remaining payments? 100. I'll say I mentioned we can talk about that later. Okay, you can call me or we can exchange about that. Any questions? So this is how, as confusing as it might be at first when you read this question, this is how you find the answer. You want so the question was, what's the remaining balance at the 200th year? And that's how you figure it out. So in your calculators, this is an annuity. This is going to be $100N . I'm going to put the interest rate in. PV is what I want. The payment is $732.50. And the future value is, I don't need that. And compute PV, and you have the value. Okay, so that's what remains after 2/3. Sorry, that's not the number. I'm copying the wrong. That can't possibly be the number. That doesn't make sense because it's only a $100,000 loan. 54,000. Okay, questions? Well, recall 1. What does recall 1 mean? We stored this amount in the calculator, so to recall it, you have to use recall 1. And I'm very concerned that you didn't know that. Have you not used the storage keys before, Diego? You'll need to use them to solve these problems. Okay. So that's the mortgage problem I wanted to solve. My solution approach. Okay. Very good, Diego. Okay, so I said I would go through one problem from each review, right? So oh no, that's the solutions, okay. Then this is the review. So let's have a look. So which one of these would you like me to do? Review 1. In review 1, which of these would you like me to do together with you? Okay, good. Diego, as long as you know how to use it. Do you know if it calculates the internal rate of return? You'll need it for that. You could use Excel probably too, if you need to. So which one of these would you like? Have a look at the document. This is document 2.6. Good. Okay, if you don't have questions about this document, I'll go to the next document. Number 2. Okay, starting 1 quarter from now, so it's in quarters it looks like, Lydia will begin to deposit $1,000 at the end of each quarter into an account to save for her retirement. She will do this for the next 30 years. Okay, 2 people want number 2. How much will Lydia have accumulated at the end of 30 years if the annual effective rate of interest is 5%? Okay. So every problem we begin, we ask, what is the timing of payments, right? Step 1. What's the timing of payments? Every quarter. She's depositing at the end of each quarter $1,000 for 30 years. So we need to convert all our variables to quarters. So 30 years is how many quarters? Okay, it's 120. Okay, we'll do 4 after. So for 120 periods, she's going to deposit 1,000 starting 1 quarter from today. So because it's 1 quarter from now, that's a regular annuity. But I want the value at the end of 30 years. So I want the future value. The other thing is the rate of the interest rate here of 5%. This is annual effective 5, but I need to convert it to a quarter. So let's do that, step 2. So I've been given the effective annual rate of 5%. You need the quarterly effective rate. What is the relationship between these two? So the way you figure it out is in factors. So 1 plus EAR is equal to how many quarters? So that means 1.05 is equal to what I want to the power of 4. And what I have to do is not divide it in 4, but put it to the 4th power, 4th root. And that I divide this exponentially to get my rate. Okay, so you use this technique to solve for the rate you need. Everything's in quarters, I need to turn the rate into a quarterly rate. Now, how do you put this in your calculator? So let's do that together. Okay, so going to my calculator, again, depending which calculator you have, you write 1.05 y to the x. A quarter could be 0.25, and then you minus the 1. That I would store in 1. Remembering it's a decimal value, probably have to multiply it by 100 and store in 1. So it's 1.2%. I'll do that again. Let's look back at what I just did. So what I need to do is I need to get the quarterly rate from the effective annual rate. So it's 5%, and I need to establish the relationship. 4 quarters makes a year. So that means I have to get I have to divide the year into quarters, but not by dividing it by 4. I have to partition it in powers. So it's a 1/4. So to put that in my calculator, what I did was 1.05 y to the x, and then I just put 0.25 equals minus 1. You could do it like that. The other way you can do it is 1.05 y to the x. You could put 4 and then flip that so it gives you the 0.25, because some exponents, some fractions you don't know. Like we know 1/4 is 0.25, but what if it was a 6? We're not so. That's going to be a repeating decimal, which you need in your calculator, and this will get it for you. And so you do that, and then equals, and then minus 1. Okay, so that will help you too. That's a good trick. Let's do it that way. Let's do it this way. So 1.05 to the power of 4, and then the inverse key, see, it gives me my 0.25 equals minus 1. And then I multiply by 100, because to use the annuity keys, or the time value of money keys, I need it as a percentage, not a decimal. So that will end up going in there. Okay, so everybody's good? So that number is stored, and I'm going to say it's stored. So I'm going to take that times 100 and store in my storage. Questions? So I have my stored interest rate. I have 120 payments. So now I just set it up. You have to express them. Wait, so I gave you the formulas that for the present value of an annuity, she's putting $1,000 every quarter at 0.25, sorry, not 0.25, at this EPR, 1/4. I just write it like this for 120 periods. But that's not the final answer. That just gives me the PV. So to get the FV, I want the future value at the end of 120 periods. So what I have to do at the end is either use the annual effective rate for 3 years, 30 years, or I could use the quarterly rate for 120 quarters. That will give me the same answer. So that's my roadmap. That's the way I answer this question. Would you like to try that? So in your calculator, all you have to do is, so this is what you would have to write for the test. You have to show me this, well, not this all along. All you really have to show me is this one. Now that if you get the hang of it, you just have to show me this step. I just did this for illustrating what the heck to do. You got to show me that. And you have to show me this and this, because you want the future value, not the present value. In your calculator, you would say 1,000, sorry, the first one is period, so 120 into n. The next one is interest, so it's recall 1 into the interest. And then PV, a payment, no, PV. It's what I want, or just leave it. If you want PV, you would just leave it blank. And then the payment is 1,000. And you can put the negative there if you like, because it's a cash outflow. And then you put 0 into FV if you want the payment, or do this the other way. I prefer to do it like this. Put 120 into n, recall 1 into the interest, put 0 into PV, the 1,000 into payment, and ask for the future value. Because that's really what we want. So if you do it this way, you still have to figure out the future value. If you do it this way, it's a better method just to get you your answer right away. So as I stressed before, my goal is to prepare you with the calculator to be able to write the CFA exam. And so you need to learn these techniques. The longer you delay learning them, you're going to feel much more frustrated about how I'm delivering the class, because I already told you at the beginning this is my intention. So yeah, you have to learn how to use your finance calculator. And what do you get? Very good, Felix. I have 66 cents. Why do I have 66 cents? Let me do it on the calculator. Let's see what we get. So the number's still there. So let's put 120, and the interest and then I'm going to put 0 into present value. The payment was 1,000. I'll enter as a negative, and then compute future value, 66 cents. Yes. Like, you'll know if you're doing things properly if you have the sense that I have. If you're a little off, well, you just read it wrong. If you're a little off, verify your method. Okay, so the answer so I would put my answer here. I'm going to put it here for illustration purpose. But the answer should be here. Now, if some of you want to continue doing step-by-step calculations, I don't recommend it. You need to learn these techniques. But that's good for practice, you know. Still, it's good to practice if you want to try entering the whole thing step by step. But you'll never have time in a test situation, high-powered, stressful test situation, to do that much transcribing. So you could put all this together in one. You could put all this together in one expression, and sometimes that creates a new formula. Just be careful. I put 30 years here with EAR, and I put 120 with the quarterly rate, so don't let that confuse you. I want you to realize these are the same thing. How's it going? Good? So that's good. Let's do number 4. Take a screenshot. Okay, it's 10 o'clock. So let's continue. I said I would do one from every page. Should I do this one as well? Okay, I'll do this one as well. So a couple requires a $400,000 loan for their budget. For their budget, they estimate that they can only afford payments of $10,000 at the end. Only afford. That's funny that I wrote it that way. At the end of each month to repay the loan, like $10,000 at the end of each month. It's a lot of money. They would like to pay off this loan in 10 years. What is the interest rate stated as an annual rate of interest compounded monthly? Okay, Felix. We'll finish this one and then go to 212. This is only 2.6. Okay, so I'll keep that in mind. It's 10 o'clock. We should have time. So all that I've done between Unit 1 and Unit 2 is taught you interest rate conversions. So it will help you solve more realistic problems to understand interest rate conversions, and just usually involves the first step where you convert everything to the timing of payments. In this one, yes, this interest, okay, let's see. So it said, what is the interest rate stated as an annual rate of interest compounded monthly? So the final answer here is as a mortgage stated rate. Okay, so you're going to want it as R112. Now the formula that you use will give you the effective annual rate, but then you have to convert it to this. The stated rate, stated monthly rate. Sorry, what did I say? If you use the formula, you should get the effective monthly rate, and then you have to convert it to the stated monthly rate. All right. So we're talking about a $400,000 loan. They can only afford $10,000 at the end of each month to repay the loan, and they want to pay it off in 10 years. What is the interest rate for that? So that's a let me take the question away to another page. All right, so they want a $400,000 loan, $10,000 payments at the end of each month, and they want to do this for 10 years. So the timing of the payments are monthly. Let me do that above. So I'm calling it step 1. Timing is monthly. It looks like I spelled that wrong. Timing is monthly, so we need to convert all our variables. The only one that looks like is necessary for my formula is the time, duration. So it's 10 years times 12 months in a year equals 120 payments. Again, 120. So this is 120. And what you want to solve for is the effective annual rate. Now, you can't do this manually. You have to use the calculator. Now, you could do it with tables or whatever. Somebody taught you before how to do that. The sophisticated way, unfortunately, is to use a financial calculator. You cannot isolate the interest rate. So this is why we have the calculator. So we have to enter everything properly to keep track of cash inflow and outflow to get a different variable. So we tell the calculator that we begin with 120 into n, and then interest is what we want, so I just leave it. And then 400,000 goes into PV, and I'm borrowing it, so it's positive. And then payments I know as well, but those will be negative payments, negative cash flows, I'm sorry. And then you say 0 into future value. We're not dealing with face value, future value like we would if we had a bond problem. So then you compute I by YR, and what do you get? So this I could call step 2. Sometimes I don't even write it. The point is that initially you have to make your conversions. So with that, So I'm going to clear TVM, and I'm going to put 120. Interest is what I want. 400,000 is what I get, but I have to pay 10,000 every month, and I'm going to overwrite FV and compute interest, and that's what we get. Very good. Good. You guys got it. Now we're not finished because that's just the effective rate. So this is the effective monthly rate. Now I have to present it like the bank would. So depending on the decimals in the instructions, you write the decimals down. And for the final answer then, R112 represents the stated rate. It just scales this over the whole year. So this would be every month. So I want the simple interest. That's what this gives. Simple interest representation over the year. So there's 12 times this. Do not round intermediate calculations. And what do you get? Very high, right? It's very high interest. So 28.1420. So let me make sure you didn't round that. So let's do it together. So I take this amount and times by 12. And that you gave me the right answer. So 28.1420 is fine. But in fact, you have to keep all the decimal places in your calculator if you're going to use it. So it's very high interest. $10,000 a month is a lot of money. It's a high interest rate to get that loan. But this, remember, this represents the simple interest. It's even more than that if you use the compounding interest, okay? But it's effectively 2.3 a month. Juan, you probably need to set your decimals on your calculator to display. I'm not sure which calculator do you have, Juan. So if you need to fix it so you see decimal places, you have to use second, format, second, I don't know. Oh yeah, sorry, I did that wrong. So you have the 9 and enter. I think that's all you do. Mine's already set to 9. Try that one. I'm not sure which calculator you have. Yeah. The decimals should be there. It's just a matter of displaying them. Let's go into the next document, unless you have questions about that one. So that was 2.6 and 7 are done. 8. Any questions on this one? This is 2.8. Great. Let's see if there's anything I want to do in here. Shall we do a stock valuation? Let's perform number 3. Let's do number 3. Unless you have another one you'd like. So this is a growing, they call it differential growth rates. So this is a situation where you have, well, maybe not this one. We just have one growth rate, I think. I think the G star exercises is to practice estimating a growth rate when you have differential growth rates. All right, so several growth rates that are predicted. So here it just says their quarterly dividends, 10% effective annuals, what they require. Okay, so the dividend will increase after 2 years to $6 from $5. So you need to make a timeline about this. Remember that investors buying stock today must wait until the next quarter to receive dividends. So a prospective investor is looking at only the dividends they'll get. Okay, the one that's just paid will continue, so it'll be $5 every quarter until 2 years from now. And now you want to value it. So let's try that together. So I'm looking at my clave, I didn't make the timeline, so let's make the timeline together. So what we're saying, well, let's do our step 1 and then make a drawing. So step 1 is identify timing of payments. I did it again because I want to make it look short form, but then it looks like the whole word and I missed a 0. So I'm just writing the whole word. Oh no, it's not monthly. That's even wrong. It's going to be quarterly. My mind is drifting quarterly. So that's pretty much, it's going to be like that always. Quarterly rates, quarterly payments for stock. So because it's quarterly, we need to make conversions of the rate. In EPR, we need, oh my goodness, given EAR, we need EPR quarter to use the formulas I gave you. So what's the relationship? 1 year is equivalent to 4 quarters. So that's like that. So this converts this into 1.1, and I still need to find this one. So what I'm going to do is take 1.1, I'm going to divide it, but in the powers, so it's going to be the 4th root minus 1. That's how I divide it, not division. It's going to be partitioned exponentially. All right. So calculate that and put it in store 1. Okay, so 1.1 to the, again, 4 flip equals minus 1. And since we're going to use our calculator, we can multiply it by 100. So that will be the rate in percentage. So it'll be 0.024136, but times 100 and store 1. So you get the percentage amount. And then what? Actually, we should probably, I mentioned in my clave that we could put this one in store 1 and the other one in store 2 because we're going to need both. We need both for this because we're going to use the annuity for one part and the perpetuity for the other. So we'll say this is store 1 and this one is store 2. And I'm writing it down so I don't forget. Well, because I might forget. Okay, so that this is the decimal amount here. Now let's make that timeline. I'm not sure why it splits everything up like this. Some sort of setting. Anyway, timeline. So they just paid a $5 dividend. And so this is year 1, this is year 2, this is Q1, Q2, Q3, Q4, and this is Q1 of the second year, Q2, Q3, but we should put the numbers on it, shouldn't we? Because I'm going to have to count. Let's do it like that. So this would be, I'll use a different color. So down here are quarters, and up here in blue will be years. So in quarters, it's 1, 2, 3, 4, 5, 6, 7, 8. And what do we see? $5 until after 2 years it'll increase, so I got to go a little bit more. Here, here. All right, because this goes on forever. We assume that corporations have infinite life because the owners could have sold their shareholding or passed it on to beneficiaries, children, relatives, spouses, or a spouse. So what do we have? $5 all the way up to here, and then a switch to 6. And this one, this is the trick here, just to draw it. So this is going to be 5, 5, 5, 5, 5, 5, 5, 5, and after 2 years it goes to 6. And there are no rates in here, that's it. So how many 5s? So there's a 5 here that's mentioned, but we don't, if we're going to look at purchasing, we don't get that one. We get the ones later. So we count. Actually, the count helps us because it tells us there's 8. So there's 8. And then after, there's a perpetuity. So it's an annuity of 8. So this is an annuity because presumably, we want the present value, right? So we are going to figure out present value of future cash flows. So this is an annuity with 8 payments. And then starting here is a perpetuity and I don't have to say how many payments because they're infinite. So that's where the formula comes from in the clave. Now I have 7. Why do I have 7? I'm just reading now. After 2 years. Okay, so I've drawn it after 2 years. I started my $6 here. Is it my clave? Well, I guess it's my interpretation. So I'm arguing with my past self that made this, that interpreted 2 years after 2 years, because for me, after 2 years. Today, it sounds like after 2 years. But anyway, let's leave mine. So I'm just looking at the clave that I gave you, and I interpreted that this should say at 2 years, and then it would work. But I'm not sure which one I should go with. So this is why you give me your written work, so I can see how you're thinking and give you part marks, because I can even think different things after a few years. So after 2 years, so I give you grades for both of those. So this is the way I interpreted it today. And for the clave, my interpretation was you tell me which one you like. I will edit my clave if necessary. Which one did you do? So the question is about after 2 years. This one should say in 2 years for this to make sense. This is fine. I mean, things like this, you can just tell me, that how you interpret it, and I will regrade if I've misunderstood or you've understood it different and it makes sense how you've interpreted it. So this would be in 2 years, then it starts to be 6. And that's why, first of all, again, I do not count the first one, but then this becomes an annuity with 7 payments. And then this is a perpetuity that starts at the 7th quarter. Which one do you like? The one that is in the clave, or does this look better? Can't even see it, right? So you like the one I did today? Me too. So I have to fix the clave. I'll send it to you. I'll edit and send it. Just because Diego said. Does anybody else agree? I think this interpretation corresponds to after 2 years. This would be in 2 years. So again, if there's any disputes about interpretation, just let me know. So let's do this one then. And don't worry about the other one. You have the answer in the clave. So for this one, it's an annuity with 8 payments, so it's $5. and that rate that I'll call the quarterly rate, and it's 8 payments plus a perpetuity with $6. And that $6 perpetuity is valued like that. That's at time 8, so it's one period before that is the perpetuity, so I have to then discount that 8 periods. So that's the value. This is the value here, one period before, so I'll call that PV. Oh, there's no room, but anyway, that's where it goes. I'll use a and so what do you get? This would be no, it separated everything again. Let's try and do this. So this would be, in our calculator, 8 into n we need to use the store 2 value, right? So it will be recall 2 and then PV is what we want. The payment is 5. And you can put it as a negative. And then FV is 0. And compute PV. And put it into storage. What do you get for the first part? So recall 2, recall 1. Wait, I didn't ever do that, did I? So this is store. Anyway, let's do this again. This is my, let me go back. My interest rate was, yes. So this is my interest rate as a percentage, and I want to store that into 2 and divide by 100. that will be stored in 1. So it's the decimal in 1 and the percentage in 2. So I want to get the percentage, put it here. So first of all, what I did was number of periods. All right, sorry, I'm jumping back and forth. I don't think I can have them on at the same time. I can if I use my phone. Anyway, you can't see the bottom of the calculator, can you? Because I changed the view. Okay, I'm just gonna do this on my calculator on the side, and you guys tell me what you get and I'll confirm. So I got that this is $35, and I have to store all these decimal places in my calculator. So I will say store 3. And for this piece over here, I can just calculate it separately. Very good, you guys got it. Sophia got it. So for this piece here, I can just calculate that as using recall 1. So this is where you're going to use recall 1, right? Because you need the decimal value to solve this. So what do you get for the second part? Perpetuity. Actually, I'll show you how I do that. I just need to position the. I'm going to position the calculator better so you can see it. I have to shrink this. There. And so you have the decimal in 1, recall 1. Now start with the more complex part. Add 1, put to the power of 8, and flip. That's the discount factor, times. So all I've done is this piece. Okay, let me do it again, and then times 6 times recall 1. That's all we're going to do. So let me do that again. So recall 1 plus 1 to the power 8, and then flip, multiply by 6, divided by recall 1. 205.6345. So I'm going to store that in 4. Okay, so that's 205. And don't forget there's many decimals, right? So I need to store that in 4. and then sum. So stored in 4. Then what I want to do is recall 3, no, recall 2. I thought I stored that other one. Oh, but I did it on the other calculator, that's why. So recall 4. So anyways, add that to your 35. And what do you get? Your final answer is recall 3 plus recall 4. $241. So you'd stock so you don't round intermediate calculations to find it's 62 is what I got. Now you round. See, we have a debate, is it 63 or 62? See, you have to keep all the decimal places to get them to bump up. I'm just repeating what I did here. Make sure it makes sense. I get 62. All right, I get 62. So that's the final answer. So this is for the interpretation after 2 years, like that timeline. Good. All right, it's 11 o'clock. Let's look at another document, okay? So I'm going to jump to 2.10. Take a screenshot. And here's 2.10. So which of 2.10 would you like me to do? Have a look. I'll give you a few minutes. So let's take a 5-minute break and get organized, because I want you to tell me one problem from each of document 2.10, 2.12, Felix had a question, and then 2.14, 2.16, maybe not. I'm not sure I went that high. I think I had a valuation summary in here. I have to see my documents. Let's see. Okay, so 213 was the, okay, so that's not it. So it's going to be 214 and 16. I don't think all the documents are in here. 13. Well, anyways, let's tell me which one you want from 210. I'm going to review your folder. So one problem from each. So the question is, which problems do you want me to do? Okay, so we're just going to go to 212. This is 210, and then 212. So Felix, I know what you're talking about now. That's the compounding, continuous compounding document. And then you have 214, and then prep questions I gave you. So these are the ones, I want one question from each of those. Let's see if we can get through the next hour. I think we'll just finish. Maybe we'll just finish the first two. So determine which questions you want me to solve. So for document 210, I'll give you a minute. We've had a really good connection the whole time. Knock on wood. It stays good. Okay, document 210. Tell me which one you want me to do, or I'll pick one. No comments? All right, so I get to pick one. Let's do another stock one because I wanted to do the growth one. Okay, let's do number 4. So this is the last page. 2 months ago, Alpha Beta Core paid a $2.50 dividend. It pays dividends quarterly. Future dividends are expected to grow at the constant rate of 1% per quarter. All right, so timing, step 1. Quarterly. So the timeline can go backwards, right? If I'm using months, let's say, quarters. Wait a second. Okay, quarters. Okay, so we're here at 0. And I'm going to use months and mark quarters. No, can't do it like that. No. What I have to do is just mark months. Okay. Now 2 months ago, there was a $2.40 dividend. And there's a constant rate of 1% growth per quarter. So did I go to the wrong place? I think I went to the wrong place. That's 3 months ago. 2 months ago, that's here. Okay. So 2 months ago that happened. And then every quarter, so 1, 2, 3, there's 4 quarters in a month. Sorry, I just said that backwards. There's 4 months in a quarter. So that puts the next one, I'll do it in blue, here. And there's a 1%, I'll put it in red. Growth rate. You're told 1% per quarter, so assume that's an effective rate. Let me make sure I did that in the clave. Okay. Last time I didn't check, and I got stuck. What did I do here? Okay, so we're going to use the G as the effective quarterly rate, and you can make a statement. So this is going to be assumed to be the effective quarterly rate. So G is 1% in the quarter. So that means the next one is going to be 240 times 1.01. And then after that, 1, 2, 3, 4 months will be the next one. And so on. And this is going forever. Now, what do I want? This is the information. As a prospective investor, they'd be looking at getting the value here because this is where they're valuing it. Now, this information was useful to determine this payment here, but notice that that's only 2 months away. If I use my formula, I'm assuming it's 4 months away, but it's not. So what I have to do is look at the timeline and just get what I can and then make adjustments. So what can I get from this? I get that, let me erase this for space. I'm not going to get this one. I will be entitled to this and future cash flows, future dividends. But if I use this one, the valuation will be here. So if I use my perpetuity formula with growth and say the first cash flow is this, the second cash flow is this, keep in mind that the first cash flow is just an amount, which would be 2.4 times 101. So this amount is 242.4, which sounds weird, doesn't it? Well, anyway, we'll go with it. Let's just go with this. So this would be 2424. 1.01. The thing is, this is our initial cash flow, but I leave it as a decimal so I don't lose I leave it like this because otherwise this is a little bit strange. And how will I get 2.424 cash flow? Well, it's all related back to the 240, and the fact that this grows, this would be relevant if I had more than one share, which most shareholders have, right? So this would be relevant that it grows by 1%. And if you multiply this by 1,000, it retains this decimal place. I mean, if it's 1,000, then you'd be getting $2,424 dividend. All right, so we leave it like this. This is why we leave things with the brackets, and this is just to show you what it is, and that you don't round it like you would the mortgage payment that we discussed. So my point is, this is C1. That's what I'm trying to get at. This is my C1. This is my C2. Let's just do this. This is C1, this is C1, and then this is the 1 plus G. So growth, it applies, this would be the second period where growth kicks in. Okay, this is C1. So for my formula, the point is, if I applied the formula to this, I would get the value here. I'm going to position this better. So this would be PV at 2 months ago. That's the best I can do if I apply the formula as is. So the first cash flow would be 241.01, and then over I minus G. And I gotta convert that one too. So I gotta convert that one. Effective annual required rate of return needs to be converted. So that means that I need so there's 4 of these in one of these. So it's going to be 1.18, I hope you guys get the hang of this now, is equal to the effective quarterly rate. So I'm going to get that and store that in my calculator. So what's going to go here is the quarterly rate minus the G, which is also a quarterly rate. I'm not finished. That will just give me the value here, and then I have to make the adjustment by month. So let me see, what do you get here? Oh, you can't see it. Let me see. Now you can see it. So tell me what you get here, and then we'll finish this together. Diego, I get a higher number. Did I do something wrong? Try again, Diego. Or did you finish the whole thing? No, you couldn't have. I get 75. 170630302, and I need to store that in 2. Right. So store that in 2 because the last step is to find PV0. I need to go here. So I need to take that lump sum amount and accumulate it 2 periods. Right? And the idea being I just have the value 2 months ago, but what is that worth today? Now you can't buy it 2 months ago, that doesn't even make sense, but just to do the math, this is what happens, okay? This is an effect of using these formula. Now you have to adjust it. So the last step is PV0 is equal to negative 2 months ago times what? How can I do this? I have to multiply by 2 months of the monthly rate. So what's 2 months of the monthly rate? We have to find it. So we have to do this again, this conversion. So what we need to do, again, repeat from above. You're given EAR, but you need the monthly rate now. And there's 12 of those, so you need to take 1.18 to the 112 minus 1 to find it. So I just repeat these calculations. So the same way that I did with the quarter, let's do this with a month. It's going to be 1.18 to the power 12 flipped equals and minus 1. I'll store it in 1. Or do I have some other storages? Hold on. I have some things stored. I need to store it in 3. I need to store that in 3. I've already overwritten everything. Recall 1, store 3. So I'm going to store that in 3. So this result would be 0.0138, like that. And so you know what to do next, right? What's your final answer? I didn't send you the clave, Diego. Pretty sure I sent them. Are you sure? Anyway, you don't need the clave right now, but I'll get them to you. I believe I just checked. Okay, I'll check what's going on with that. All right, let's finish this. Email me, Diego, just to make sure if I forget. So what we need to do is take our stored value and multiply by 1 plus this squared. Diego gets an answer. Diego, shouldn't it be higher? It should be bigger than 75. Oh yeah, you get bigger than 75, okay. Oops, how did I turn this on now? I still need to learn how to stop this thing. I don't even know. Oh, it was recording something or other. Okay. Sorry. So you want to recall 2. This is 1 plus recall 3 squared. So you probably want to do it like this. Recall 3 plus 1 equals squared times recall 2 equals. And what do you get? Okay, Diego is right. The final answer is 77.27. Any problems with that? Let me make sure that that's right. In my clave. Yeah, 77.27. Very good. I got it right. Okay, 11:30. Let's look at. Okay, 212 was the continuous compounding. Let's talk about that. And then I will leave these for you guys. Review these and everything else. We're not going to talk about this again. Next class, we're going to begin Unit 3. Okay? So I'm going to send you the new material. So this is done. And yeah, this is finished. Practice, practice, practice. And if you have questions, I can make an office hour session that we can solve problems together online. Or I can meet you in person if you like. If you really like that, we'll figure it out. Some students do better in person, I have to say. Well, anyway, I'm just thinking of a few students that needed one-on-one. But we can do one-on-one by distance as well. There's no reason we don't have to do that. I just want to check my sound. So let's do compound. Great one, I'm glad you got it. So let's do continuous compounding. 212. Felix, you're still here? So he's like, what is this all about? All right, so what this is a setting that's used a lot in finance, where we imagine interest is compounding continuously over a period of time. Now, if we have the simple interest notion of that, like the stated rate, we can actually state that and find its equivalent annual rate. So what I'm going to do before I go into this is go back to this chart. I call it the interest rate conversion map. I think I might have changed the name in this handout. Okay, Felix is here. So this is my summary sheet for you for conversions. And then I have another summary for valuation. So what you see here, I'm going to take this piece All right, so let's rewrite this. And this is probably how you see, and I'm leaving a little space here because I'm going to fit in the continuous compounding over there. So the way I'm going to rewrite this is probably familiar to you because of the relationship between the stated rate and the effective rate above on this handout. I could also write this as, right? And then this becomes, anyone object to that? So if I had the stated rate, I would have to divide it by 2 and then square it, and then those would be equal. But that would be the same if I wrote the stated quarterly rate and divide it by 4 to make it the effective rate, and then add 1 and raise it to 4. That would also be true. And then if I had the stated monthly rate like a mortgage, I have to rewrite that, and divided it by 12, that would be the effective monthly rate, and I could add 1 and to the power 12, and that would also be the effective annual rate. So all of these are 2 semi-annual periods, 4 quarters, 12 months, 365 days. Everyone okay so far? So those are all the same. I've just combined the first formula on that sheet, which is the conversion from stated to effective, combine them into one string of formula. And I didn't do that initially because right now it's going to hit home. What I can do with this is I'm going to add on what if, so we're going smaller and smaller, semi-annual periods, quarters, months, days, and the smallest interval that we consider in finance is continuous, instantaneous interval. And we write that as, we express that as R0. So you could get a continuously compounded rate, an annual rate compounded continuously. Let me say it clearly. So this represents, like a stated rate does, the annual rate compounded continuously, and it's very useful in valuation in finance, okay? So what are we dividing by? Well, always we're dividing by the number of intervals, right? The number of intervals in a year, if they're monthly, is 12. The number of intervals in a year, if they're daily, is 365. Well, how many intervals if they're infinitely many? So now what we're talking about is limits. So I'm going to express this, if you remember, at the top of that sheet that I referenced before with the interest rate conversions and these two formulas, converting from stated to effective or effective to effective. Sorry. If you remember, let me show you. Here it says the subscript n represents the length of the compounding interval in years, so it's like a half, a quarter. The flip is the number of compounding periods, okay? So this is really 1 over n. So we're dividing by 1 over n. It seems weird, but there's no perfect way to do this, it seems. But that's what we're going to do. So I'm going to use the notation 1 over n, and I'm going to say make that n, which represents the fraction of the year, right? The interval that we're talking about. So this is the fraction of the year. It's getting bigger, otherwise n is getting smaller. Wait. Sorry, I did that back. The fraction of the year. Yeah, it's getting smaller and smaller. So the fraction of the year, the interval length, right? So it's and 1 365, 1 12, 1 quarter. It's becoming 0. Well, when n becomes 0, 1 over n becomes infinite, doesn't it? All right, so let me finish the expression. This would also be 1 over n. And you'll never have to repeat this, but I'm just trying to show you where this fits in, so maybe it helps. So when the fraction of the year, the interval that we're talking about for compounding, is small, becomes smaller and smaller. In other words, it's compounding continuously. We use a limit to express this. So this is the extreme. That's why I put it here. It's in the far left of all of these formula here. So what is this? Well, you learn in calculus that this expression actually is ER0. So this is the exponential function. This gives the exponential function. And understanding compounding, this is a representation. If we write it like this must be the same as EAR. All right, so this is going to be maybe blurry for some of you remember limits, but basically I've found a way to make the interval go smaller and smaller and smaller. So this is the interval getting smaller and smaller and smaller. When the interval gets smaller, then over a year, that's infinitely many compounding periods. So this is called continuous compounding. This is the annual rate compounded continuously, and it relates to the effective annual rate like this. So 1 plus EAR is equal to e to the R0. And you must have seen this in math somewhere in your MECU classes that this is the case. But I'm not going to ask you to see this again. I'm just trying to link it so you know that if you get a continuously compounded rate, it's a stated rate and it's equal to 1 plus EAR. I mean, e to the power of the continuously compounded rate is equal to 1 plus EAR. So now we can use this to solve problems. Note, there is no effective continuously compounded rate. We just speak about it as a stated rate because that's not even practical. You can't get that rate instantaneously. Anyway, it works. It helps with solving theoretical math problems. So this is the relationship. You can review that video if it helps. And so I can answer questions regarding continuous compounding. If I want to find the effective annual rate, this would be the way to find it. If I want to find the stated rate, I will find it doing this, the stated continuously compounded rate. This is how I get it. So these are the two formula you need. And then all I do below is I say, well, you use it just like you would if you want the basic time value of money relationship with a stated continuously compounded rate. This is how it would look. Basically, it's the 1 plus EAR piece that comes from. So you've probably seen this in math in school. You remember the PERT formula. This is where it comes from. Okay? And I've made more general expressions here, like at any point in time, as long as you have the principal amount at time little t, you can, with the duration of investment t periods, this is how we learn the time value of money expression. If we did this annual, we would write it like that. And then we could also write it like this if we knew the R0, the rate, the annual continuously compounded rate. So there are some questions, there are some exercises. This is basically a summary with an exercise at the bottom for you to practice. Let me take it to another page. I just screwed that up. I want to go So here's the problem. Your bank offers you a certificate which pays you $100 at the end of each of the following 3 years, carrying a stated annual continuously compounded interest rate. So what they're saying is R0 is equal to 8%. So with the formula that I gave you, then 1 plus EAR is e to the R0. So we can find EAR by doing e to the 0.08 minus 1. Then you'll have the effective annual rate, and since the timing of payments is each 3 years, that's the rate you have to use, the EAR. Okay, so the timing so you need to convert the continuously compounded rate into an annual rate. How do you put this in your calculator? .08. Where's my E? Oh, it's over there. So wait. So if I do second like that, 0.08 equals, no, it didn't work. So I have to do 0.08 second. That's how it works. Okay, you put the number first, then second function to activate e to the x. Okay, so you'll have to figure out if you have a different calculator how you get that. So -1, and you get 0.083287. Store it. Just like the bank will store it. We gotta store all those decimal places. So find the present value using the annuity formula. EAR is the interest rate. So that's stored. All you have to do is set up the annuity of 3 payments . So in your calculator, you would put 3 and n, and then recall 1 times 100 to put into interest, and then PV is what you want. So it's 100 into PMT, and then override what's in FV, you don't need that, and compute PV. What do you get? Yes, 256.19. All right, good. Okay, so that's how you do that. That page was just giving you the formula for the conversion. So think about it, and you can use this now. It's 11:50, so I'm going to let you go. So I'm leaving you with these documents to practice. If you don't have the claves, email me and I will send them. But I do believe I sent you everything. So with that, I will wish you a happy weekend and good studying. Get some rest, and we'll talk next week. Unless you want to meet with me in person or online, let me know. Text me and let me know if you want to get together for some extra questions, because otherwise I am starting, I'm putting my number in, I am going to be starting Unit 3 next week. So on the next test, it'll be Unit 3, Unit 4 material. That's my goal. And let me know if you have any other questions. You can write me, you can text me. So have a good weekend. Bye.